Okay. Hello, guys. My name is Lazaro. Thank you for attending this competitive programming team lecture review. We'll be going over what Giri went over, or the problem that he solved on Thursday, which was the Fibonacci string sequence. There's a couple of people here with us in the room, so don't be afraid to type in chat. David is right next to it, so he can look at the live stream in case there's any extra questions from our viewers. But the first question I want to ask is, do you guys know what the Fibonacci sequence is? Yeah?
Yeah, actually, yeah. I think everyone's knows it, right?
Yeah, you want to say it?
Huh?
You want to say it?
Like the first few digits of it?
Yeah, or the general approach algorithm for it.
The previous number plus the next number is the result of the next number after that.
Yeah,
yeah.
So, as he said, there's usually two Fibonacci sequences you guys might see. You might see where it first starts off with a 0, and then a 1, and then it does exactly what he said. You take the previous two and add them up. So 0 plus 1 is 1, and then 1 plus 1 is 2, and then 2 plus 1 is 3, and then so on and so forth. The other sequence, it just drops to 0, and it starts off with 1, 1, and then it goes to the same thing. So no real big difference there. But since our problem is about the Fibonacci, it's good that we have this down and we really understand it. Okay. But our problem is a little bit unique. First off, I do want to say, because he did mention this as well, we could generalize this. It doesn't always have to start off at 0, 1, or 1, 1. It can start off at any number you want. It could start off at 7, and then 2, and then you can just add the last two. It's be 9, it's be 11, then so on and so forth. Because the important thing is the algorithm itself, which says the Fibonacci of n is going to be equal to the Fibonacci of n minus 2 plus n minus 1. So any two numbers that you begin with, you can plug it in, and then you can create a sequence based off of that. So let's erase this. Now that we know what the Fibonacci is, well, you guys already knew, but a little review. So this problem is a little bit unique. It doesn't use numbers. It uses strings, but it's still the exact same approach. If you start off with the string A, that's your first one, and then the second one is B. What would the third one be? C, okay. Does anyone agree with her? You don't? Okay.
If we're going by where the numbers are placed in the alphabet, then yeah, it would be C.
C, okay. C? You don't answer.
I wouldn't.
So let's remember our algorithm. And let's remember that we're trying to do the exact same thing as a Fibonacci sequence, but now with strings. So this third one is going to look at n minus 2, which is going to be A, and then plus n minus 1, which is going to be B, correct? So if we were to add that A plus B, we add those strings, we will be getting AB. Kind of threw you off because AB, like, I understand why you guys said C.
Yeah.
But yeah, so now that we no longer have that deceiving us, does anyone want to tell us what the fourth one would be? Yes?
Is it AB squared?
Sorry?
AB squared.
Okay, AB squared. By squared, you mean AB, AB?
Yes.
Okay.
No, ABB, I think.
ABB?
Yes.
Okay. Anyone else?
BAB.
Say that?
BAB.
BAB, okay. Anyone else? Oh, if these is our current sequence of strings, what would the fourth one be if we're following the Fibonacci sequence?
ABB.
ABB, okay.
BAB.
BAB, all right. Raise your hand if you think it's BAB. Okay, we have 1. Didn't you say it?
I'm thinking about it again. No, I'm not sure anymore.
Okay. Raise your hand if you think it's ABB. All right, so majority of you think it's ABB, but the answer is BAB. The reason for that is because remember that the Fibonacci formula, it's f of n is equal to f of n minus 2 plus f of n minus 1. So it looks at the one before and then adds the one after.
I never thought about which ones to add in what order.
So yeah, that's a good point. For numbers, it doesn't really matter. It's commutative. But here for strings, it does matter, and specifically for this problem, it matters as well.
Oh, so is it always going to be f of n minus 2 plus f of n? There's no like other way of doing it, right?
Yeah, for this case, yeah, it does need to follow this order, yeah. Okay, okay. I was like, am I doing something wrong? All right, cool. All right, so we've gotten this far. Now let's actually get into what the problem is that he gave us. Let me just erase everything. Actually, I'll leave that there. The problem is if we're giving two numbers, n and k, what letter is in the kth index of f of n? So that might be a little bit confusing. So let's go over an example. Let's say n is equal to 3, and let's say k is equal to 1. And remember, we're talking about strings. We start off with just these two up here. What would f of n? Wow, I really messed that up. What is f of n equal to here? If we're starting off, we're given a and b for 0 and 1. Anyone? You don't have to raise your hand. You just like say it.
No. Oh, if it's the same as the formula, then it would be n minus 2 and k minus 1 plus both of them.
Yeah. So in this case, what is n? 3, right? And then what's the formula?
It's 3 minus 2 plus 1 minus 1.
So 3 minus 2 is just 1, and then plus f of 2, right?
Yeah.
So yeah, we can continue breaking that up a little bit further, but now let's just write the index. Let's say you were given that f of 0 is a, f of 1 is b. Here, if we were looking at this, let's just, for now, erase this. What is f of n equal to? Oh, f of 3 equal to? Say that again, sorry.
Sorry?
I didn't hear you, sorry.
Oh, BAB.
Yeah, does everyone agree with that?
You should repeat in case the microphone didn't.
Oh, yeah, you're totally right. So Kunze said it will be BAB, and that is the correct answer. Because if f of 0 is a, and then f of 1 is b, if we were to continue that formula, we will see that f of 2 will be ab, and that makes sense, because f of 2 minus 2 is 0, which is a, and then f of 2 minus 1, it's f of 1, which is b. That's where we get f of b. We continue doing that, and we find that our third one is BAB. So now we understand what this n means from the inputs we're given. Like I said, k means the index at that string. So what is index 1 at this string? Yeah, a, yeah. So, because index 0 will be b, index 1 will be a, and then index 2 will be b as well. So this was pretty easy, right? We can easily just do it out in our mind, actually, because it's just n of 3, and then index k. But let's say we're given something much more complex. Let's say our two inputs was n is equal to 45, and then k is equal to 27. Can we do this in a computer? We know the algorithm for the Fibonacci strings, right? But would it be possible to do n is equal to 45?
Yeah, sure, you could.
Yeah, okay. Yeah.
Might cause overflow possibly.
Yes, exactly. So since we're dealing with strings, we're no longer dealing with numbers. Numbers will be extremely easy to do that, right? It wouldn't be that large, the Fibonacci sequence of n is equal to 45. It wouldn't be that big. But since we're dealing with strings, it could be a really long string, and that can mess us up big time.
Yeah.
Either time complexity, or no, not really time complexity, space complexity. It probably won't fit in memory, so it can mess us up. So how do we solve it?
How about we look at the middle and see which part we should be really looking at, so we're not reading everything.
Okay. So at the middle of the string?
Or the middle of the, like for example, it's n equals 45. We might start with maybe halfway through.
Yeah.
You know, like not from n equals 1.
Okay. So that's a good point. Let's say instead of starting from n is equal to 0 and then 1 and 2 and 3 and 4, let's just start at n is equal to 20, right? But if we start at n is equal to 20, that means we're going to need information from n is equal to 18 and n is equal to 19. And since we never computed those, we can't really do that, right? So yeah, that's the issue. The issue is that we need to start from the bottom and go all the way to the top. We need to start from, yeah?
Wait, quick question. So the question is asking what is the k's index? So when you had n is as like 3 and k is 1, the answer was just a?
Yes.
Oh, okay.
Yeah, okay. So Kunze had a good idea, start from the middle, but the only issue is that we need the previous two Fibonacci numbers, or strings in this case, to compute the current one. So we can't start from the middle. We do need to start at 0 and work our way up to 45. So what did Giri tell us to do? Giri told us to, actually, let's see if you guys can find the pattern. So this is for the strings, right? Now let's look at the numbers. Is there any connection between the string and the number? Wait, no, not you. Okay, sorry. Not you either.
String and a number?
Yeah, is there any connections between, let's call this S, right? And then let's call this F. Let's say this is the Fibonacci sequence for numbers, and then this is the Fibonacci sequence for strings. Is there any connection that you guys see between these numbers and the strings?
They have the same position, essentially.
Yes? Is there anything else?
The number of characters are the same as the Fibonacci sequence.
Exactly. So this has a length of 1. There's only one character. And then the Fibonacci sequence for numbers, it's 1. And then this has 3. And then the number at the exact same position is 3 as well. So why does this help us? Why do we care about this? We care about it because now it makes things a little bit easier for us. We no longer really have to deal with the string. We can only deal with the number. Why do I say we can only deal with the number? Remember we're given k, right? And we want to find the letter or the character that is at index k for the Fibonacci string of n. Damn, this is so complex with so many n's and k's. Wow. If you guys get lost, I guess let me know. I don't care. I'll repeat it. Okay. But remember, we want to find the index, the character at index k. If we only deal with strings, if we only deal with numbers, I'm sorry, and k is also a number, what does that tell us? If, let's say n was 45, right? And then let's say k was 2. What would this be? What would this answer be? Do we have to go all the way to 45? No. All right. Why?
Wait, I had it in my head. 1 second. Sorry. Sorry, continue. Like, writing.
Yeah, it's fine. All right. So we only want the second index for this case. We don't want to waste our time going all the way to 45. Instead, we can look at the beginning. Instead, we can look at the beginning, and we know that k, when it's equal to 2, it's going to be either A or B. Does that make sense? Because the string is only built up of A's and B's. Hey, good in you. So let's try to visualize something here. Let's say this is the string we're at. Let's say this is n, 27, or 30. We can break this up into 2 things. We can break this up into n minus 2 and n minus 1. Because remember, this string itself is built up of n minus 2, which, let's just say, is this portion. And it's also built up of n minus 1. Which is that portion. If our k was 5, where we want to look? We would want to look in the left or in the right? So if our k is equal to 5, would we want to look in the left or would we want to look in the right?
In the right, because we start from 0. Yeah, that's why I like stop for a sec.
Okay, anyone else? Everyone agrees?
I concur.
Yes, all right. Oh, David concurs. All right, that's good. That's usually good, right? All right. So, why did you say that?
Oh, well, we take the length of the string and then we look for 5, right? So.
Yeah. Perfect. Yeah.
Yeah.
So we look for 5. But remember, we're not dealing with numbers. Instead, we're not dealing with strings. We don't want to deal with strings. Strings is too messy, there's too much overhead, and it might run us out of memory. So we want to deal with numbers. Using the Fibonacci sequence of numbers, can we tell whether we should look in the left or right? Yes, all right, she's nodding. All right, that's one yes.
Yeah, the Fibonacci sequence of numbers would tell you the length of the string.
Yeah, perfect. So like we learned in the beginning, the Fibonacci sequence of numbers is going to tell us the length of the string. Let's say, what did I say? I said this is S of 27, random number. If this is a Fibonacci sequence for strings, when n is equal to 27, we get this long string, right? But S of 25 is equal to just this part. You guys agree with that? Only this left part? Yeah? Anyone want to tell me why?
Wait, what was the question again? About this?
If S of 27 is equal to this long string, what would S of 25 be equal to?
The left part?
Why?
Because it's n minus 2.
Yep, exactly. That's the algorithm. It's S of n minus 2. So 27 minus 2 is going to be only this part right here. Because remember, we're adding it. So 25 is going to be equal to 25 is going to be equal to A, B, B, A, B. What is S of 26?
The right side.
Perfect. Why?
And then minus 1.
Yeah, so 27 minus 1 is going to be 26. And since we know what 27 is, we can figure out what 26 is. So we have this right side. Perfect. Now to just really drill this again, let's remember, make sure this is in frame, I don't know if it will be. Let's remember that S of n is equal to S of n minus 2 plus S of n minus 1. So S of 27 is equal to S of n minus 2, which 27 minus 2 is 26. Sorry, it's 25. And then 27 minus 1 is 26. We add those two together, we get 27. That means we can build up to 27, or if we know 27, we can build down to both 25 and 26.
I have a question. So if we're building up from 27, right? If we're going to 28 or 29, don't we need 26 for that? Oh, but we can get 26.
Yeah, it's because it just carries over. Yeah. All right, perfect. So, like you said, since remember we don't want to deal with strings, it's too much memory. We can also figure out whether our k is on the left or right. Because f of 27 is going to be equal to what? No.
F of 25 plus F of 26.
Yes? And what would that give you?
31. No.
Yo, I was like, wow, that's
Sorry.
I was longer than I thought. So remember what I said, that there's a connection between the Fibonacci of numbers and the Fibonacci of strings. What was that connection?
The character length is the same as it would be in the Fibonacci sequence.
Yeah, the length of the string for the sequence of the Fibonacci sequence of strings, right, is going to be equal to the Fibonacci sequence of numbers. In that case, what would it be?
F of 27.
Yeah.
It would have the same length of characters as the actual Fibonacci of 27.
Of the string of 27, right?
Well, yeah, the string of 27,
Yeah.
but F of 27. Well, wouldn't 27 be the index in the Fibonacci sequence?
Yes, 27 is the number of, yes, in the Fibonacci sequence. But in this case, let's say 27 was this string. Yes? 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. In this case, it would be 10. Why would it be 10? Because it's just the length of this string. Because that is the connection between numbers and strings.
To be clear, it's not actually 10.
Yeah, no, there's no way it's 10. Like, it's a bigger number.
You're asking me the actual way.
No, oh, okay, no. No, it was taking respect to what this is.
It's just an example, right?
Yeah, this is just an example. F of, I don't even know the number, it's big. But let's just carry on with it being 10. All right, and now let's say our k, what did I say it was, 5?
Yeah.
Let's say our k is 5. Since we're only dealing with numbers, we're not really dealing with the strings, because remember, it'll be too large and won't fit in memory. Can we still know whether we want to go left or right? From just this information, do we know if we want to look at the left or right? You're nodding yes. Why?
Because 5 is on it would be on the right side. There's 9 indices.
What makes you say that?
Because we have the amount of characters in the string to send.
Uh-huh.
And so to figure out what side you have to look on, you just get the k, the index that you're looking
Did you take into account that we need to look at f of 25 and f 26?
You were asking what side we should look on, or what?
Yes, if k is equal to 5, do we want to look at in the left or in the right? Remember, our left is 25, and then our right is 26. I probably shouldn't have erased it, but I wanted to make you only guys see the number. Yeah, you were saying something? Yeah. Okay, yeah, perfect. Yes. Okay, so we're looking at the Fibonacci sequence, right? Which, yeah, this is good, because this is actually the pivot point where it does start to get hard. We're looking at the Fibonacci sequence, which is just 1 and then 1, and then the algorithm is for any number we're currently on, look at the previous two. Add n minus 2, which would be this one right here, then n minus 1, which is that one, and then we get 2. Then we continue doing that. Then we get 3, then we get 5, then we get 8. Yeah. And then we go to 13, and so on and so forth. The algorithm for this is f of n is equal to f of n minus 2 plus f of n minus 1. Does this make sense?
Yeah.
Exactly. This is built with recursion. And memorization if you want to be efficient.
Can we practice it by saying that in the problem, they save the first
Yeah, the first
7
two
values? Well, actually, I think they saved the first 7.
in the V-judge problem.
Yeah, in the V-judge, they saved the first 7.
They saved the first 7.
Yeah, they put those in there already. Like those.
Are you sure?
I think it's those.
Because I solved it, and they only gave you A and B.
Well, you only really need the first one.
Yeah, exactly. Okay, so this is the algorithm for the Fibonacci sequence. But we're doing something a little bit different. Instead of doing it with numbers, we're doing it with strings, which is the exact same thing. If we're given A and B, we go back to the algorithm. The third one is going to be equal to 3 minus 2.
What is the A here?
Oh, instead of numbers now, we have strings. Yeah.
So A would be 1, or A would be 1?
Yeah, so A in this case, it's replacing 1, and then B in this case, it's also replacing 1. So if we want to continue building this up, the third one will be AB. And then the fourth one will be BAB. Do you see like the pattern, how it's similar to this one? We look at the previous two and then add them together.
Yeah, it's just a bit confusing. It looks like it's being multiplied when I have to back this way.
It's being added. Like
Yeah.
the strings are concatenated.
Yeah.
Right? So they're being built together.
Yeah, just think of squishing the previous two strings together. That's how we get this one, ABB, AB.
And it's important to note that the prior one comes first.
Yeah, yes.
Oh, those are the order matters.
And for the strings, yes, the order does matter for this specific problem, which is why I wrote it out like this. First, we want to look at the one 2 steps behind, and then plus the one 1 step behind. So that's pretty much it. But then there was one more connection we made, which is that there's a pattern or some sort of a connection between the numbers and the strings. Can you guys see it, like right now? Or if you heard me, you can also just say it. Like, do you see a pattern between the numbers and the strings? Yeah, it's exactly that. So here we have 1 letter, and in the number sequence we only have 1. Same thing here, 1 and 1. Here we have 2 letters. In the Fibonacci number sequence we have 2. At the exact position is the same thing. So that's the connection we made. And now the problem we're trying to solve is given two numbers, n and k, we want to find the Fibonacci string sequence at n, and then what character is at index k. So it's pretty hard. For example, here, if n was equal to, let's say this was 3, like 1, 2, and 3. If n is equal to 3 and k is equal to 1, the answer would be B.
Well, it wouldn't it be the fourth one?
Yeah, if you start off at 0, it would be the fourth one, yeah.
And we're assuming that we're not going to be doing like a false and like a wrong.
No, all of our inputs are going to be correct if you have the right algorithm. Okay, cool. You know what? I'll leave this up here. So we don't want to deal with strings. I've said this like a lot of times, but I'll say it one more time. We don't want to deal with strings because it's just not efficient. We might run out of memory and out of space, and they might not accept our solution. Instead, what we do want to do is work with numbers, which is basically the same thing because it tells us how many characters are in that string. But the general solution that we're getting at is that we can break down a string. If we're currently at this string right here, and n is equal to 1, 0, 1, 2, 3, 4. If n is equal to 4 and we're currently at this string, we know that the character at index k, it's either in AB or BAB. The reason for that is because AB and BAB, they come together to make this string. So you can tear it apart and solve an easier problem instead of solving this long string. And we do that by the numbers because we're looking at this. We're looking at if the number, the Fibonacci sequence of numbers, if n is equal to 27, and let's say that number is 10, we can tell whether we, going back to what you said, Danny, we can tell whether we should look at the left or right by looking at f of 25 and f of 26. Let's say f of 25 is equal to 4. Let's say f of 26 is equal to 6. Should we look at f25 or f26 if our k is 5? F of 26. Because remember, this represents the strings. If the string is 10 characters long, and we want to index at 5, then we can break it down further and only look at f26 because that contains 6 numbers. F of 25 only contains 4 characters, which is less than what our k is. So we know it's not going to contain k. We know that f of 26 is going to contain a. That made sense? Yeah? Are you sure? You guys sure?
Can you do like a visual example
With the string?
Yeah, with a string following that sequence.
Yeah. Yeah, that should be fine. All right, so let's go back to this. Let's say we have A, B, B, A, B. If we're not looking at numbers, we're only looking at the strings. Let's say this was a string. This has 10 characters. F of 27 has 10 characters. We know that pattern. We know there's a connection. So we know that this is S of 27. Where the S just represents the Fibonacci sequence for strings. This sequence. And then F represents the number sequence, that sequence. If F of 25 is 4, what would be S of 25? Well, if this is S of 27, what is S of 25? You need this information to answer it.
S of 27 minus S of 26.
Not exactly, no.
Kind of right.
Yeah, if you like move it around in the algorithm,
Yeah.
yes. Okay, but tell me what substring in this string.
Oh, that's 25, so that would be the leftmost, right?
Yeah, it will be the leftmost, and it's how many characters?
4 first characters.
The first 4 characters, exactly. So, can we all agree it'll be that section right there? Yeah.
Yep.
Will be S of 26. The other 6 characters, right? If K is 5, which one do we want to look at?
The one on the right.
The one on the right? Good. Now I'm going to drill it all the way down until we get the answer. Oof, the numbers are not going to line up at all. What number is the one on the right? S of what? 26, yeah. All right, now we're only looking at this string. What do we have to do to K? Do we keep K at 5? Why not?
That would be true index.
Yeah, that's right. What do we have to do?
Subtract from the total number of characters.
Not exactly. We don't have to subtract it from the total number of characters, but we do have to subtract it from something. Yeah, you raise your hand.
Subtracted from the length of the first string.
Exactly. Since we know that K is within this section, we want to kind of reset it and let this be 0. And we do that by subtracting the length of the first section. We know our K is within here. So we need to remove this little section of it. So now K, what is K going to be now? Yeah, it's going to be 1. Now what? Let's say, actually, no, let me ask you guys to see if like you caught what we have to do. From here, how do we know S of 24 and then S of 25?
What do you mean by S of 24 and 25? The number of characters that would be the Fibonacci number that.
Yeah, exactly. So S of 24 and S of 25, we have to look at the Fibonacci sequence and see what number that gives us. Once we look at that, we know where we can split it. Let's say, for this example, S of 24 is this section right here. And then S of 25 is this section here. If K is 1, where do we want to look?
Left.
Yeah. Why?
Because there's that's the, the index 1 is still on the left, the left fragment, which would be 24, I think.
Yeah. Yeah, well, you actually answered everything I was going to ask you. So now we have to look at S of 24.
Do we change K?
Good question. Do we change K in this scenario? No? All right. Why?
Because it's on the left side, not the right side.
Exactly. Yeah, there's no, think of this like first we were looking at the right side, and we had to remove this extra padding to it to reset it back to 0. But in this case, since we are staying on the left side, we don't have to do the extra step.
So there's no overflow.
Yeah, exactly.
Wait, I have a question. To get the answer, why do you need to divide S of 26? Can't you just get the index 1 there and then
let's say our n was huge. Let's say the maximum is 45, which would be a really long string, right? Which is the reasons why we're looking only at the numbers. Right now, we're doing this visually, but we're going to be working only with the numbers. That's because the string is too long, and k might be the last string. It'll be very inefficient.
K might be the last string.
It might be the last character.
The last character.
Yeah, the last character. So if, for example, if this was extremely long, you're saying to just stop dividing, right? Let's just look at this string as well and just index right now. That might not work, because the position where we do have to index, this string already might be too long for us to put into memory, and our algorithm would fail. All right, cool. So we all agree, right? The k, we do not have to change it. We all agree on that?
So I actually want to ask, do we all know why we're not building this string?
Dude, I swear, I said it a lot of times.
I know, but I just wanted to make sure that maybe some people who don't.
Okay, so why aren't we working with a string? Exactly, yeah. Because a string might just be way too crazy long for us to store it in our memory, and we might get space limit exceeded. All right, so k is equal to 1. At this point, let's just say that's that part. This is this part. Just for the hell of it as well. So this is 2. This is still not matching up at all, but whatever. Left or right?
Right.
Right, okay. Why?
N minus 1.
Okay. Yes, that's correct. Everyone agrees with that? That we have to look at the right side? Cool. Now we're left to s of 0. Yeah. No, actually, s of 1, sorry. Yeah. Which is what? If we're 0 indexing, we start counting at 0. So this was 0, then this was 1.
Oh.
What would be s of 1? Yeah.
But hold on. I don't get it. Because if we're looking at the S of 2, which you will be A, our S of 1 should be A.
Yeah, because 2 minus 2 would be 0.
Yeah.
Oh no, yeah, you're totally right. You're totally right. We can't go based off of this. Yeah. Yeah, it will be A. You're totally right. Thank you. Okay, and then since we looked at the right side, do we keep or change k? Change it to what? To 0, yeah. So k is not equal to 0. And as I believe you said it, right, that we'll be doing this recursively? Yeah. And this is our base case right here. When we reach 1 or 0, we know it's either A or B. In this case, it's 1. That sequence does not line up with this, so just forget that for now. In this case, it's just 1. So we return A. And that is the answer for this.
Base case is whether n equals 0 or k.
No, whether n is equal to 1 or n is equal to 0. Yeah. So what did we learn here? We learned that we need to break it down to solve it a little bit easier, right? Can we do this with the number sequence? Okay, that's 2 nods. I think you nodded. No, you didn't nod.
Like
Okay.
a string of number characters.
Huh?
Is it like a string of number characters?
No, I use me like the actual Fibonacci number sequence.
Yeah.
Yeah.
Okay, 2 nods. Anyone here? Okay, that's 3 nods. Okay. Obviously, you know. You agree? Right?
I'm not sure.
You're not sure?
I don't know how you do that.
Okay. You're also not sure? All right, cool. That's actually, that's good. That's fine. Now we're going to write the algorithm. If I mess up the algorithm, let me know. When we're doing something recursively, what's the first thing that we put? The base case. What would the base case be in this scenario? 0 or 1, yeah. So if what is equal to 0 or to 1? If n is equal to 0 to 1, yeah. What do we do? Shut up. Let's say in the problem statement, it tells you this. Let's say, just for consistency, I'll stay with s. Let's say s of 0 is equal to a. And then s of 1 is equal to b. If n is equal to 0, what do we want to return? Wait, who said that? You? Oh, you? Okay, perfect. Yes, we do want to return a. Do you guys know why?
Because it's the first.
Yeah, exactly. It's the first two inputs that we have. Looking at Fibonacci, we can't go anything further back than 1, because we can't do 1 minus 2. And the same thing for 0. Or you can go into the negatives, but we're not doing that. So if n is equal to 0, now it's Python. If n is equal to 0, we return a. If n is equal to 1, what do we do? Wait, someone else. Someone different. Yeah, go for it, man. Wait. Oh, I thought you said me. Okay, you said B. Cool. We all agree with that? That all makes sense? Perfect. So what now? What were we doing with the strings? We have to figure out what? Where to look, right? We have to figure out whether we should be looking in the left or we should be looking in the right. How can we do that?
Another if statement.
Yes, another if statement, okay. What's the condition?
The value of k with the corresponding Fibonacci number of n minus 2 and n minus 1.
Yeah, that's exactly it. So remember, we're not dealing with strings. Remember, we're dealing with numbers. So if k is less than or equal to, I'm quiet on purpose. Let me just finish it. What does f of n minus 1 mean? Is that the left side or the right side?
Right.
The right side. You guys agree?
Yeah.
Yeah. Okay. Agree. Okay. Perfect. Agree. Yeah. Now, what is this telling you? If k is less than or equal to f of n minus 1. That's telling you k is where? On the left side or right side? On the left side. Yeah. So this is telling us that k is currently on the left side of where we're looking. What should we do? Let's actually name this method. What should we do? Remember, we're doing this recursively. So what do we want to do in here? We know our answer is on the left side. We want to continue further breaking it down. So what now? Okay. But remember, we don't have the string. We only have the number. So we don't know what character is there. That makes sense?
Yeah.
Okay, cool. Instead, what we want to do is continue further breaking it down.
Yeah, you'd want to reduce k, right? Oh wait, no, in this case you'd be looking at the right or the left?
In this case, we'll be looking at the left.
So when you want to keep k the same?
So we keep the k the same, but do we do logic here, or do we call the method again?
Were you gonna say something? Oh, you call for the value of n minus 1, you call the solve.
Yeah, so we call the method again, but now, well, is we n minus 2, because it's on the left side. Yeah. So now what we want to do is return solve, which is this method we're currently in. We're doing this recursively. We know our answer is on the left side, so now we want to look at n minus 2, which is that left side. And then we want to pass it, okay. Does this make sense to everyone? Yeah? Let me ask you guys one more time. Why are we doing this recursively?
So that we can get, we break down the string like smaller and smaller until we reach either A or B.
Exactly. So we can continue further breaking it down until we reach n is equal to 0 or n is equal to 1, which is either A or B. Perfect. This is if it's in the left. How do we do if it's on the right? First off, actually, let's just say we continue with another if. Let's say we want another if. You could do an else, but we're not going to do that because we're smart.
Else is not necessary.
You're right. Wait, it would have been elif.
Else.
Elf. Yeah. So what were you saying?
If k is greater than f, or
Flip the navigator.
Yeah, yeah.
and then we solve the n minus 1.
What now?
N minus 1.
And k minus the length of, one second, sorry.
Yeah, that's fine.
Just allergies, by the way. And k minus the
It's not
length-
COVID.
Yeah, and k minus the length of n minus 2. Right?
Yes, yes. Make sense to everyone? Because remember, I think it was what you said, how we're going to remove that left-hand side. And that's exactly what we're doing here. We're resetting that k. We're not really resetting it, but we're changing that k because we're only looking at the right side now. Since we're only looking at the right side, we first have to remove the characters that's in the left side. And we do that by doing k minus f of n minus 2. Yeah.
Okay, we're comparing k in these two ifs. Then why are we not comparing k in the top if statement?
Because these are our best base cases. If at that point we only have one option. At that point, k better be 0.
Well, actually, n could be 2, right? And your choice is either that k is 1 or 0. And then that would determine your choice.
Yeah, but and then that too we can further break it down. You could add that and that other
No, that's just
check.
conversion.
Yeah, but since we can further break it down, we might as well.
Okay.
Sorry. Yeah.
I see, if we were to compare the if conditions, if we were to check like f of n minus 2 is, if f of n minus 2 is less than k, we know for sure that we can go to the right. And if it is, but I'm not sure how we're sure that we need to go to the left if f of n minus 1 is greater than or equal to k. Like if we compare with f of
You can come up here if you want, by the way. Okay.
So for the second if statement, we're looking at the rightmost.
Actually, I think I see what he's saying.
Wait,
Because if it is.
are we looking here?
Yeah, no, up there.
Here?
Actually. Yeah, it has to be less than -2, read right. Because it will be the length of the left string. If it's less than the length of the left string.
Oh.
Which is less than the right.
Yeah, he's totally right. He's totally right.
And he's right.
Yeah.
Good catch.
Yeah. Yeah, round of applause for that. Yeah. Yeah, because this is going to equal the length of that left side substring. So if k is less than or equal to that, then we know it is going to be on the left. Yeah, good catch. Good catch. All right, cool.
So we change on the bottom.
Yeah, that would. Yeah, as well. All right, we're done. Are we? Wait, you know it. No.
Just one important question.
You know it too. Shut up.
What's the question?
You too, Kunza.
What's the time space complexity?
It's not the space complexity for it's a week of n. Yeah.
But I mean, I don't understand. So the time complexity would be like really long, right?
No, it'll be O of n.
O of n.
Yeah.
Would it?
Well, I was gonna ask, like, we're making the assumption that where we're finding the Fibonacci number and would be already computed.
Yeah. That's exactly it. We first, before we do this method, we first have to compute our Fibonacci sequence. So outside of this, I can draw it, whatever. Or not draw it, write it. Say outside of this, we have array equal to an array or list in Python, whatever. Not empty. Initialize it with 1 and then 1. And then, should I do Java? Nah. Sorry.
It's okay.
I'm so sorry. All right, that's how we would do the Fibonacci sequence. We start off with 1 and 1, because that's our base cases. We need those two to do 3. So not everything from the range of 2 and beyond. Yes. From everything from 2 up to n, which n is our input. We want to do I minus 2, which is our last, which will be 1. And then last is going to be I minus 1, which since we're starting off with 2, it's going to be 1. Last is going to equal to 1. Last is going to equal to 1. We add them, and then we append it. Does this make sense to you? Like it's Python, but it's pretty simple, right? Okay.
Oh, and then we said f equal to r.
F equal to r.
Yeah, because we're
Oh, yeah, because we're doing it here. Yeah, you're right, you're right. Yeah, I was totally not consistent with that. Thank you.
Yeah, I was just wondering, like, how does it like concatenate? Like when you return A and you return B, like I don't know how it just like assumes that like they're together.
So there's no concatenation here, because we're not really using the strings. If we were to be using the strings, it would be A, B, B, A, or something like that, right? But if we continue breaking it down further and further and further, we're going to end up at either A or B.
yeah, we don't need to build this thing.
Yeah.
We don't need to do it at all.
Yeah, that's what's just messing me up.
Yeah, that is the confusing part.
Yeah, yeah.
Are you guys also like on the same blockage as I am? I guess you're okay, Danny. You're fine. You're a genius.
No.
You got this.
How does it know like what the string looks like at the end when you
We
call
don't
the
need,
function?
that's the thing.
Yeah,
We
we
don't need to know.
we don't need to know because we're doing it by the numbers. By the numbers, it tells us how many characters are in there, but we know it's either going to be A or B.
Like, let's say there is a you know, a string that's the 40 foot, right? So that's associated with, it's associated with a number.
Yeah, with the, like the 40 index of the
Yeah, the 43 and 44, right? 45 is the concatenation of string 43 and 44, right? Because those are the last ones, that's it.
Yeah, but no, but like, how does it like, I'm not an expert at Python. How does it concatenate? Like when you return A, doesn't it just return A?
So,
Then like you return, like let's
oh,
say
I think I know.
or-
I think I know what's the issue here. Here, we're not figuring out this sequence. We're just figuring out the character that's at index k for f of n.
So K is a one character in the big string that we're given. Like I say, if n is 40, we have the 40th string. We're trying to find the K character.
Yeah.
Which one is it? Is it A? Is it B? That's all we really want to know.
Yeah.
And they give us A and B.
You think what you think is like this recursive function
Like, how
is
does it-
building this?
Yeah, like I mean, what I'm thinking is like, I mean, it doesn't have to save it, you know, but like, how does it add it? You know, like how does, like, let's say I get, I want to get AB, you know, it returns A,
No,
and it returns B.
we're not doing that here ever.
Have you taken data structure?
Well, I'm taking it right now.
Oh, okay. Have you done binary search yet?
No, but I know what that is.
Ye-
It's actually like erasing, well, yeah, how do I explain this without talking about like letters?
Like you're cutting, you're breaking it down into smaller pieces.
Yeah, you have, conceptually you have like the whole string, but it's only the like you only have the number to build it, or only the number to, know about it. And then you like cut it in half and you like, you can tell by like,
You have to
Yeah.
do it.
No, what we do need to build is the number sequence.
Yeah, we're not doing that.
That's all we really need to. Let's run through an example. Okay.
Yeah, do that one.
Like in a normal, like let's say we could actually calculate the normal, Fibonacci sequence. Like, that wouldn't fail then.
No, yeah, I would. Why not?
It's recursion.
It doesn't matter. Like worst case scenario, we're always cutting it down by 1.
Yeah.
And that's going to go from whatever number you're at down by 1. So let's say we're 50, down by 1, 49, 48, 47, 46. It's going to go from 0 to 50. That's all then.
Let's say K is all the way to the right.
Yeah.
You just keep, then 45 turns into 44, turns into 43, and so on until you're at 1.
But then when you're at 1, you have to go back up.
No, you don't.
No.
You don't. You already have an answer. That's
Yeah.
your case.
So let's run through this example.
Maybe the n equals 0 and equals 1 is
I think it will clear it up if we run through this. So here we have n is equal to 4, and then n is equal to 3. We pass it to that method. Let's say we already have that Fibonacci sequence. We already did that, so we already know the numbers. I should always also add the numbers.
So the answer there would be
Whoa, chill, man. Relax.
A. I mean, we already know the answer. It's just like running through the algorithm.
I mean, yeah, you can just look at it, and then the third one, 0, 1, 2, 3. Yeah, A. We're not ready for you, Danny.
No, just also having a little trouble understanding it, but maybe running through it can make it more. more
Yeah. No, that's going to be confusing.
No, and then n would be those numbers.
Yeah, but it has all these numbers. And remember, we have like the S of n minus 2 stuff. No, this is S and F. So this is the Fibonacci sequence for a string. This is Fibonacci sequence for numbers. Let's say n is equal to 4, k is equal to 3. We pass it into here. Is n equal to 0? It's not. Is n equal to 1? It's not. So we get to this part. Is k less than or equal to f of n minus 2? What is 4 minus 2? Damn, really? Okay. Yeah, it's 2. It's 2. It is 2. So now we want to do that comparison. We want to compare if k is less than or equal to f of 2. What is f of 2? No, man, stop. Not you.
You call it recursively to know the answer to that, right?
No, f we already built here.
So
It's
all
just the
of-
number sequence.
All of that happened before solve.
Yes. So now f of 2, what is it?
Oh.
Remember, this is our sequence for numbers. You said 2?
Yeah.
Who agrees with them? You agree? Yes, it would be AB if we were looking at the Fibonacci sequence for strings. So yeah, no, but if you were to change it for the numbers, you were right. It's 2. Then I just give the answer. All right, so yes, it is 2.
Yep.
So is k less than or equal to 2? Remember, k is 3. So it's 2 less than or equal to 3?
So it's 3 less than equal to 2.
No. Oh yeah, if k, what the hell did I say? Is 3 less than or equal to 2? Thank you. No? No. All right, good. Thank you, guys, so much for that. Yes, it's not. What does that tell us? Remember, we started with 4, which is ABB, AB. We never built this Fibonacci sequence of strings. We never built it, but we have it here just visually. We started off with n is equal to 4, and we want k is equal to 3. What does that tell us now that we know that 3 is, when 3 less than or equal to 2 is false? Tells us it's on which side. If this returns false, and this returns true.
Right.
Okay, thank you, yeah, on the right side. Is that true? If we were looking at this right here, and where n is equal to 4, and k is equal to 3, is it going to be on the right side?
Wait, say it again.
If we're looking at this string right here, and then which is equal to n is equal to 4, our index k, when it's equal to 3, is it going to fall on the left or right side? All right, remember, if we're here, the left side is this, no?
Yeah.
And then the right side is this, no?
Right.
And then if k is equal to 3, is it true that it's going to be on the right side?
Yeah.
Yeah. Because the index 3 is on the right side.
Yes.
All right, cool. All right, so we continue. This returns false. This, it is going to return true. Because f of n minus 2.
Maybe you could write down the like the new values of n.
Oh, we haven't called it again.
Yeah, yeah.
So now let's get to this second if. Is 3 greater than f of n minus 2? We know n is equal to 4. F of 2 is equal to 2. So is 3 greater than 2? It is, right? So that's where we get to this part. Now we call it recursively. Now n is equal to 3. And k is going to be equal to what? One? Yeah. All right, what next? I want you guys to guide me now. We called this function again because this if statement returned true. Now our updated n is equal to 3 and k is equal to 1. So tell me, is this going to return true? No.
No.
How about this one?
No.
What about here?
3.
Dude, stop. You know this.
Let me check if 1 is less than.
Okay.
True.
Less than or equal to what?
Yeah, if it's less than f of 1, which is 1.
So it returns.
Less than or equal, so it would be true.
It will be true, right?
Yeah, then you have to recursively call it again.
Yeah. So now we recursively call. Now n is 1. K is still 1. All right, walk me through it again.
No, go back to the base. That's the last if statement will be false.
Which base case?
N equals false.
Yep. And then we return b. Is that correct?
0, 1, 2. Yeah, 3. Yeah.
3, 0, 1, 2, 3.
So is it be at the end? Yeah, because it's 94, so the last index is 3. It's like 0.
Did we mess up somewhere?
Actually, did
No, I think.
Why is it returning a?
I thought it was
0, 1, 2, 2.
a.
Actually, no, you're right.
Oh, but wouldn't last statement will be false because 1 cannot be greater than 1, so it should be right.
Oh, so it should be
Wait, wait.
less than. Which is right. Yeah,
Wait, what you
because the
say?
index starts at 0.
Right.
Oh.
Oh, yeah, what is
Yeah, it needs to be strictly less than.
Then, yeah, then the last
Greater than or
if
equal to.
statement should be
Less than or
equals.
equal to.
Yeah.
Yeah, good point. So I actually did that on purpose for you guys to think about this activity.
I passed the test.
Are you serious?
Yeah, I'm serious. All right, cool. So let's go over that. Why can we not put the equal sign here? Who was it that said it? Was it you or her? No, you don't talk. It's her. It was you. Yeah, it was you who caught it. Okay,
I
go.
don't know what you said, though.
So you guys,
You want to come up here? Okay.
I had it a minute ago.
Well, they can't both have equals, right?
No, yeah, only one has to.
That
Needs to.
wouldn't make sense because then that would make both true.
Yeah.
That would be a conundrum.
Indeed.
could be an overlapping.
Oh, someone had their hand up here?
I think, I'm not sure, but I think it's because since we're dealing with the index of the number and we started from 0 to equal, it will be on the right side. Like when dividing the whole thing,
Oh,
we
yeah.
think about it.
Because, yeah, so if the length is 3,
That's a good point. Yes.
equals 0, 1, 2, right? And then the one, the first index of the right will be a 3.
Yeah.
Yeah.
Okay, that's a good point. And then we can. Let's go over the example where it failed. Let's say we were here in 2, and our k was 1, right? If our k is 1, and minus 2 is equal to 1. Yes. Okay. Okay. Yeah, that would fail. Let's say our n is equal to 2. So we're right here. If our k is equal to 1, then if we had this case here equal to 0, then 1 is less than or equal to f of n minus 2. F of n minus 2 is going to be back to 0 and it's going to return 1. So those two are going to be equal to each other, and then we're going to recursively call it, and what it's going to return is going to be returning a, which is the incorrect answer. It should be returning b instead, because k was 1 when we started here. So yeah, that's also a good catch. That I definitely planned.
Yeah, I think we're.
Yeah, I'm pretty. This is like, this is it. This is the whole algorithm. Did it clear up what you were saying? Because you thought we were actually building all of this here.
Yeah, I thought like in turn it was gonna be using some type of like memoization to save it in an array and then like look it up.
Well, the memoization is actually that part when we're trying to fill in an array of fit values.
The only part that we do fill up is the number sequence.
Yeah, that's it. And one extra caveat, the maximum number
It's 45,
is
right?
45. So actually, well, it's fun. So it's not O of n. Since the most is at most 45, it's going to be O of 45. So this is an algorithm that will run in constant time.
All right, relax.
Okay, it's a caveat.
Yeah, relax. Yeah, constant time.
Because it's at most 45.
Yeah.
Why is it at most 45?
That's just the constraint.
In the problem statement, it says that n would be at most 45. So that basically, if you're going off of what he's saying, for any problem you do, if you just start off with the highest number, it's always going to be constant. It could be n cubed, but it's constant time. Constant time, boys, we did it. Sorting, constant. Okay. All right, so do you have any more questions, like for all of this?
So is this dynamic programming?
Okay, sorry, I had to crack my back. Is this dynamic programming?
You mentioned memoization. Is memoization a dynamic programming?
That is, yeah. If we were building this with memoization and recursion, that would have been dynamic programming, because we're using the last two to build up the other one. But here we're breaking it down. And we're not really using a sub-problem to solve. No, we are. Yeah, this is dynamic programming. Because we're solving a smaller problem to finally solve the bigger problem. And that's what dynamic programming is. We break it up and then solve the easier problem. And then with that solution, we can solve the bigger problem.
So basically what you're doing is that for any value n, you're always just going to have to go all the way down to the base case to solve it?
Yes, because the string is only going to contain A or B. So yeah, we want to only stop at those two base cases, when n is equal to 0 or n is equal to 1.
Or so you're not actually building the string, but you can sort of visualize it as if you were?
If we just use the numbers, we know how many characters are in the string, which is more than enough.
Right, but if you visualize it, then in a certain way you're still like splitting up the strings.
Yeah, this part right here is still doing that split, like whether we should go to the left or to the right. Cool? Huh? Dude, if you guys get this in an interview now, you're for sure getting in.
It's
The-
one of the easier
Let's go.
questions.
I think maybe not very likely.
No.
Bang.
Yeah.
You'll get a hard one.
Microsoft, Google. No, okay, so yeah, going to what Danny said, this is from VJudge, which is like competitive programming type of questions, which he made you sign up, right, to VJudge?
I signed up,
Yeah, okay.
but I'm not, like, I think I did, but I don't know if I got, like, do you have to get accepted or something?
No, it's just like creating an account. Yeah, he's gonna give you these types of questions. All those types of questions are from actual competitive programming competitions, and it's not common for companies to use those questions. They usually use questions from leak code. But still, if you're doing an actual competition for FIU and you get this question, you know how to solve it.
Yeah, don't get discouraged though. It's pretty rare to get a problem like that hard on an interview.
Yeah, like, like, my problem, like, what I'm just, like, having, like, trouble, like, wrapping my head around is the fact that you're looking up the character. So it's like, to me in my head, it's like, you have to do it on the string. Because I know you can, like, you can get the length of the string, right?
Mhm.
You could get it in constant memory, I guess, right? That's, like, okay. But looking it up, like, how do you know, like, this one is this one? Like, you have to build it out.
Yeah, so, and that's exactly why we had to do that, breaking it down. Because we know, based off the Fibonacci sequence, the next number is going to be a concatenation of the previous two. So, and that's the pattern. For example, BAB is a concatenation of these two. So instead of looking at the whole thing, we can just know whether we should be looking at n-2 or n-1. And that makes it easier for us. And we don't have to look at the string. We can just look at the number. Why can we do that? Because it's all going to boil down to either A or B, because those were our two starting characters.
You're never looking up the character though. You're
Yeah.
just using the fact that you know, well, n, whatever number n is, it could be like a big number. You just have to keep breaking it down, like in the part where it says like if k, the two if statements there. You just have to break it down all the way down until you get to either 0 or 1, and then you return either A or B. You're never actually looking anything up. It's
Yeah.
kind of confusing though, because the question talks about strings, but then you need to use the numbers to solve it.
So yeah, so when n was equal to 4, we were here. But by just looking at the string, we know we have 5 characters there, right? But k is equal to 3, and that's more than enough to tell us whether we should be looking at the left, which is n minus 2, or the right, n minus 1. From there, we know we're going to be going to the right, which we can further break down into B is on the left, and then AB is the right. Now our k is going to be updated to 1. We know we want to continue to the right. Right, yeah, which is this. And then this is built of 2 things, and then we can further break that down into A or B, which once we get to 0 or to 1, we can just return that. Because it's all starting from A or from B.
Oh, what do you mean by return that?
Like this part, that will be our answer at that k index.
What do you mean by that?
Like to return the answer, if we get to n is equal to 0, we just return A. So we just continue further breaking it down and down and down. Because it all starts from somewhere, and it started from A and B. Yeah, it's hard to like wrap your mind around. Giri definitely does that, and this is actually an easy problem. That's sad.
For him it's easy, or what?
Dude, no, for him this is like, he wakes up and does this in his sleep. We did computational geometry. That was, oh my god, that was horrible. All right, so yeah, now you guys know the algorithm for it. So I suggest you look at the video or look at Giri's lecture, which is also on our YouTube. For this Saturday, when he does do the competition, you guys should easily be able to solve this question.
It's only going to have one question?
No, he might have a harder one.
Yeah.
Good luck. Like, that's all I'm going to say.
So the competition's happening tomorrow?
Yeah, the competition is tomorrow from 12 to 5.
Yeah.
What day is the beginner lecture?
So they're Wednesdays, and they start not next week because Giri's out of town. The
Yeah.
week after. So September the 8th. That's when the beginner lecture starts.
Okay, and for the live stream, thank you guys for watching. Hopefully you enjoyed the video. Goodbye.
For Saturday, where is the competition at?
So it's virtually, or you can come in person, or like anywhere, meet up with people if you want. It's gonna be through VJudge. He's gonna give us the name of the competition, and then once I have the name, I'll put it in the Discord chat. It all follows the same format. I think it's like FIU, and then the year and the month. But since you guys are new, I'll just put it in the chat and tag everyone. It should end by itself.
So is it like writing numbers again?
Yeah, go for it.
Look at like how
This is like so
Yeah.
hard to visualize.
Yeah, to visualize it, yeah, it does. Like you don't you're not used to it.
Yeah.
Oh, like
It is
also, like, is it, like if it's an even number, it always starts with A. Did you guys ever write this out to like, Fibonacci,
So yeah,
like 5, and then like see if there was an actual pattern? Yeah, yeah.
in 7, it's gonna have 5 first, which starts with a B.
Yeah.
So, oh shit, but 7's odd. Oh, I see what you're saying.
Yeah.
Okay, Let's write it out. Let's see.
I don't know any, actually, I don't even know any principal echoes of my, I don't know what that is.
Holy fuck. You see, this is why we didn't mess with the strings.
Yeah.
It's already getting big.
Actually didn't.
Yeah, I only wrote up until one more after that one. That's
Okay,
all I did.
let's
I got the third part.
But how
That's
exactly?
kinda
be.
And you love this Python.
No, fuck it. Let's just do it
You
like that.
read it.
Python?
You read it.
Are you guys
What?
Python or
What did I
Java?
read?
I want to transfer this.
What
I want to like
the
transfer
fuck?
Python.
Wait, hold on.
Does it really follow that pattern?
Looking at
Don't worry about all that. You feel more complete when you do Java.
Yeah. I guess it does follow that pattern.
Yeah, well,
But that's still a special case.
yeah, that is. You can add it to the like. It doesn't
Yeah,
care.
yeah. Or you can do it from the beginning, like before building everything out. You can just do it there.
Yeah.
So like the pattern that he noticed is that, wait, go ahead, use it.
Oh, like anytime it's even in the Fibonacci, in the Fibonacci sequence, it's gonna start with an A, but if it's odd, it's gonna start with a B.
That's cool. I didn't even notice that. Nice.
Does that like change anything?
No.
No, I don't know.
It's still a special case because let's say like k is not equal to 0, you still have to do all of that.
Is you're taking data structures?
Yeah.
The only sad part was
Have
the
you done any
Python,
problems
but
with
it's
recursion?
like-
Like,
Yeah.
Yeah, I've done,
Saturday.
Yeah, 'cause you did recursion outbreak.
Thank you.
Yes, that's
Lester, you wanna do an in-person Saturday?
I can't do it in person
Yeah,
Saturdays.
yeah, but,
You could. You and Ricky could.
Yeah,
Oh,
yeah.
okay.
So that's
Also, you just like taught yourself a little bit?
If, hold on a minute, so if for the competitions you wanna meet, we could meet in person,
Oh,
it's on
that's good.
Saturdays. And it's gonna, we used to have it in the computer lab over there.
Yeah.
And we just work on the problems that Giri gives us on those Saturdays. But, in case he doesn't, you know,
We can do it ourselves.
we can just do.
Yeah, I already sent out this problem, and it's also in the description of the video.
Are there gonna be like any classes next week? Because I heard you mention that
Yeah.
Gary's not gonna be around.
Yeah, Gary's not gonna be there, so he doesn't start until next week.
Yeah.
And since Gary isn't gonna be there, I'm not also gonna be giving a class.
Alright, so no classes next week.
Are you in one of?
Yeah, go ahead.
I wanna do
one
some
of those classes.
Yeah.
What classes are they?
That's it.
I'm reading techniques.
Oh, I think I'm in your class. Yeah.
I wanna
I
get
think you're all in this.
You guys
got
think
right.
I'll go to
Okay.
Uh-huh.
right,
Yeah.
4 and an
Yeah.
With Giri or with
With Giri.
I think you're all in this.
Wanna
class.
go?
Yeah, he said that he'd play a video lecture.
Yeah, for next week.
Yeah, we have
Even though we don't have a class next week, we
And
do
then,
have our first body meeting.
so it's gonna go through
coming
all of
up
this.
next
Yeah.
Friday.
It's gonna
Yeah.
get this.
Exactly, yeah.
So
Present
look out.
K,
Yeah,
if
yeah.
K, but greater than N minus 2. We don't know what N minus 2 is. So it's gonna
Oh.
cause.
We do,
How do we know?
because we
Yeah,
built
we'll be
F here.
updating it and
Oh.
F is a number sequence, and we do this first, and then we solve this.
Alright, thank you guys so much.
All right, take care, man.
Take
the
care.
number sequence?
Thanks for
Thank you for
coming.
coming.
That's how we start here for our number sequence.
Yeah, this
So
is
we,
basically just making the Fibonacci sequence.
yeah,
And then it puts it on an array.
yeah.
So we do use an array.
Yes, but not for the string.
There's the time.
We never concat anything for the string. We do build the number sequence.
And also, if you're doing it in Java, there's a way to never like use a string
I
either.
don't mind doing that.
Yeah, but that's what I was like. I was like,
You know
So-
that
I
build.
saw him.
Yeah, you're making this and then you like, you call the function, wait, actually,
Well,
how would that access the array?
It's just global. It's
Oh,
fine.
it's global, okay.
so let's say we have
Like
this
a
thing.
mic.
It goes like this, right?
Uh huh.
It's like
This
a
is like
gift.
actual like.
What up the answer? I was in his place. You saw my story.
Yeah, it's in
Yeah.
That was
an
the
array. So then
that was
f
the
of,
pool that I
okay, so
went
we're
to.
calling f of 4, and then it's
Yeah,
gonna
it's
look
nice.
at
It's a small
f
room,
of
but it's got a
2,
gym.
Yeah.
right?
It's got
Subtracted that. So this is
Oh, my story is yeah.
Oh,
It's his
3,
place.
4, 5.
Uh huh.
So we're gonna look at this guy right here. It's 2.
Yeah, it's 2.
You got
So
the.
is 2.
That's the
Forestry?
No, it's the one by one line.
Oh,
The one right in front of
The
it is
one.
bigger.
That's
That's
the
the one.
So then
Okay,
we're
so
gonna
that's
skip
the
that
one.
one.
That
And
one.
we're gonna go into this one.
That one. Who's on my story? You saw
The same thing.
Yeah.
And Adrian.
Adrian.
Yeah, that's
That's it.
true.
That's all we need.
So we're gonna return the same thing again. N minus 1. So we're gonna return f of 3.
Not that.
And this is the right side. So now we go from here to this one right here.
Yeah. So then, okay, so f of 3.
Uh-huh.
So we basically look at this right here, 3. Right, and then k, which
Yeah, because his
is
internship, well, I mean, his
3
internship was with the company.
minus 3,
But
which
he
is
was
0.
remote, so he went there once just to visit.
Right?
Okay.
This is
And minus 2 is 2, 0, 1, 2. No, it'll be 1.
Oh,
Yeah,
no.
Yeah,
you're
yeah,
right.
I know, I do.
Oh, yeah, I think you looked at the
4
other
minus
day.
2.
Really?
Yeah, we went to eat ramen.
Oh, iPod?
Oh, no, in Wynwood.
Wait, was that with someone with Tommy and?
Yeah, yeah.
Doesn't
and
it look
some guy named
at
Daniel
f
and
of
Chang?
4 minus 2?
Yeah.
Sorry, say it again?
Okay, so it didn't execute this, right?
Uh-huh.
But then we're going
No,
to this
for
one.
real, no. I
Uh-huh.
went to
But we're
his
still
place.
trying to find f of
This
4.
is his place now. He lives at the
Yes.
Right?
my
So
one
then,
town.
Really? Wait, that's
4,
That's the
we
pool.
put it in here, right?
Uh-huh.
Right?
So 3,
Okay.
That's the pool.
And then
I like
here
that.
it's
I know where he has a gym there too.
3.
It's 3 minus f of 4.
Yeah. He actually told me I could pass by
No,
Sunday.
f of 2.
I mean, sorry, f of 2, yeah.
Yeah.
Oh, sweet.
So
Okay, and then
yeah,
f of
that's
2
what I might be
is
doing.
0, 1, 2.
Really important. I do have
2,
to pay
yes.
for my car.
Right.
So 3 minus 2 is 1.
Yeah, you're right.
So I
Yeah,
can
3
park
minus
and not
1
get
is.
like
Oh, sorry.
Yeah, no.
not get towed or fined.
3 minus 2.
That didn't
You'll
pay.
get towed for not playing class.
Yeah.
Okay, well if you
So
don't
we're
pay
gonna look
your
at
classes, because that
0,
goes
1,
into
2,
your
3.
tuition of parking.
Yeah, n is now 3.
So,
So we're gonna
yeah,
look
K
at-
is
they'll
1.
give you a citation.
Yeah, which is the right side of 4. Okay.
I've gotten
So
in
we
trouble
look at
for
1.
Uh-huh.
parking a car
It's
that's
gonna output B, right?
Yeah, okay.
And what we were doing is 4, 0, 1, 2, 3. And I wanted A.
to do the first assignment, but he's fine.
No, 0, 1.
Oh, you're
Because K is
right.
1.
Yeah,
I
yeah.
have an assignment.
0, 1. Okay, yeah.
This first week, I don't even have my homework.
Okay.
And I'm waiting for some professor.
And then here, we can continue breaking it down.
What do you mean?
Here, we can look at either the left or right.
But don't we already have the answers?
No, we only give the answer when n is equal to 1 or n is equal to 0.
Oh, okay, okay.
So we continue doing that recursion.
Yeah, the n gets smaller.
Yeah.
It's spring 2020, basically.
So let's continue. Now n is equal to 3 and k is equal to 1. We're here. Let's rerun it again. Let me just erase all this.
It doesn't say Elon Musk, it says Elon Musk. Elon Musk.
3, comma K.
Elon Musk.
Boom, that just gets all of this.
Yeah.
3.
I hate Elon Musk. Look, yes.
No, this now it's 1 because remember we updated
yeah,
it.
you're right.
Elon Musk all the time. You already know about this. I need you.
Anytime he comes out with like a new project, it like fails on stage.
So 3 minus 2.
Or he talks about like the bot, you know the Tesla bot?
Yeah.
He doesn't have an actual working bot, he just has pictures and like
Yeah, go ahead.
graphics. Yeah. And then like the Boston Dynamics, you know Boston Dynamics?
That's not
So
true.
they have an
Yeah.
actual working
And it
robot.
goes down here.
Yeah,
and
so
then this
there's
is,
them,
1.
which they did 7 years ago.
We call this
And
a
there's Elon
function.
Musk with a guy in a
Which is
suit
true.
dancing.
Yep.
And then we're gonna
Pretending to
put
be a
that again
robot,
in here, which
and
is
then
1
showing
minus 1, which is
pictures.
0, comma.
No, now it's 3 minus 1,
Here
so
are the
we go to
stats
2.
That we pulled from thin air and we said, yeah, investors, please invest in this product.
No, 2, 2.
Hype up the Tesla.
Because it was 3 when we were here, right?
Look at my network.
Do you remember the
Oh, but we're putting.
K is equal to 1.
Oh, the Cybertruck?
Oh,
No,
yeah.
Cyber-
Yeah,
But-
yeah,
but
yeah,
N is equal to
yeah,
3.
Yeah, dude, yeah,
Yeah.
that was embarrassing.
So 3 minus 1 is 2.
Yeah,
And then this is 1.
Bro, it's been like three years,
That's what
right?
3 minus 2, which is that's what 1. That's what 1 is 1. 1 is
Oh, yeah,
0.
3 years.
So it's 2
And
comma
it's
0.
not even out on market yet.
Like, I don't know. I don't
Okay.
really keep up with that, with Tesla.
So then 0, 1, 2. Look at the
He's
zeros.
like, you know Theranos?
Yeah.
See, like,
Yeah.
this is.
Elizabeth Holmes.
Yes.
They
I'm waiting for her
This is what-
case.
For her case,
Yeah.
right? Yeah, because she was
This is-
pregnant, and
This
so
is-
they weren't,
oh.
prosecuting her, so they have to wait until.
This is exponent. Like, ultimately,
Yeah,
you have
so
to do
like,
it.
yeah, because she
This
basically
is,
lied
exponential.
about her
um,
product and had
Like, this is
investors.
exponential time, right?
Oh, she was
No,
yeah.
how?
Billions of dollars.
'Cause remember, we're stopping at N.
That work.
Yeah.
Yeah, but like to build it out.
Didn't work.
How is it? How?
She had nothing, and
So-
she had like investors investing money, and she didn't have like a working product. And when she did have it out,
Okay,
it
so-
was dysfunctional because it would say,
Let's
oh,
say I want to get 2
you
comma.
have diabetes.
Let's say I want to get the
And it
fifth
was a
term.
wrong test. So
Mhm.
basically her product was
Right.
this, right? You need a blood test, right? You need to like take off
8 minus
vials,
2 is
put a
6.
needle,
And the point is that people are thinking needles. Why don't we just do a little prick and it'll do the test in an hour.
You get
It just
7
completes it.
7 plus 6.
Yeah.
Right. How does that
Not
even work?
realistic.
Not realistic at all. But
You get
she's
the-
young, she's
Wait, no.
charismatic.
So, okay,
and
let's say
she's a
n,
woman, and the
let's say it was a big
investors
number,
want
right? Let's say n was 50.
you know, old men.
We
Wait,
start at 0.
Sorry, can we just
And then,
so
like,
let's
they
do
were like,
5
okay,
because I just realized we're not even
Okay.
at that.
So gave her
So then
money,
this is
pumped
five,
money
so
into
we're gonna
her
get
body,
five.
and she had nothing.
So then this
And
is
then once they
3,
found out,
and
they
this is 4.
devalued her company.
Right?
When
And then
people
how many
spoke out
makes
against, yeah, no, it's not a work.
So, but we're gonna look at the
She
array though.
scammed.
So then
She
it's 3
scammed.
I think it's
investors.
3 and 5, no?
And that was
Huh?
fraud.
3 and 5, because I think you're looking at the index.
Yeah.
Yeah.
At this
but
point, you're not even
it's,
trying to
like,
hide, bro.
Okay, I see, Yeah.
She'd be like, doing stuff, you know what, why don't I
and
just show
then
you
we
how
plug
to
it
do
in, which
it?
is
She manipulated a lot of
This is,
people and she signed a lot of,
3 plus
what's the
5.
document called so that nobody
And
like
then
speaks outside the company? for
array dot
security?
append.
NDA.
NDA. She signed a lot
See,
of
but
NDAs
what
so
I'm-
that nobody would
like,
say that her
how do we
business
know
doesn't actually work.
Wow.
Yeah.
That's 3 and 5.
Look, this is 5 years
'Cause
ago.
we
Fraud
had
is
already built it.
actually,
Where?
So we start with 1 and 1, right?
This is before they found out she was a fraud.
We start with 1 and 1. So now let's say n is 5. We start off at 2. 2 minus 2 is 0, which last is now going to be equal to 1. Because array of 0 is 1, right?
And look how she's dressed.
Here,
What is that
now
array?
2 minus 1 is 1. So array of 1 is 1. Now we append that. Now we add 2. Now we go to 3. 3 minus 2, 1. 3 minus 1, 2. Sorry. Okay, 3 minus 2 is 1. And then 3 minus 1 is 2. So array of 1 is going to be 1. Array of 2 is 2.
And then here's her
And now we append it and we add
That's not her real
3.
proof.
So you see how we're building it up from the bottom and then slowly getting up there?
Yeah, like a bottom up. Yeah.
Exactly. But we're stopping at n. So let's say n is 50. We start at 0. We really start at 2 because we already knew this were 1 and 1. But let's just say we start at 0. And we go to 50.
Yeah, and then we just access it.
And then we access the last 2 because we already computed it.
Why?
If this was exponential, it will be like whatever 2 to the n or something.
Sound commanding.
But that's not the case
Getting a deep voice.
because we're going from 0 to whatever our n is.
We got billions of dollars, got rich.
But so it's O of n though.
It's all been, yes.
The
Okay.
broken chair.
That sure is. Okay.
R.I.P.
That makes a lot more
Yeah.
sense. Because I was when you initially said he said something like, oh, like
Rest in peace, the fuck.
we don't have like memory or like we
Like
don't
a movie
access.
Yeah,
by-
so that's for the strings. Because these strings could be extremely long, and if we try to store it in an array, or the computer can't handle it. It runs out of memory.
Like with Ryan
Yeah,
Reynolds.
'cause the problem would
Yeah.
be the time.
Yeah, exactly.
Would be the space of the computer.
Yeah, like 100 integer is different than a 100 character.
Exactly. Exactly.
Yeah.
Can I take a Zara with you?
100.
Yeah. Dude, yeah, it's really hard to like visualize it and see why you need to break it down. Like it takes a while.
What are you guys doing Sunday?
I remember, yeah, like I did Adrian
Fellow Peruvian.
Yeah, I know.
Wait, fellow what?
Peruvian.
I'm Peruvian.
Oh, you too? Hey! Yeah, me too.
Peruvian party.
Are you from, are you like,
So,
Were you born
yeah, no,
here
like
or
I hate
here?
recursion.
Oh,
Like,
okay.
I remember I learned recursion. and
Yeah,
then-
where's your
I mean,
family
I learned recursion,
Lima.
and then like I didn't do it for
Cool,
like 2
cool.
weeks.
Uh,
I forgot it.
Yeah.
I had to relearn it.
Yeah.
I'm like, bro, like, why, like,
Nice.
every single
Yeah,
time I
my
look at it, I'm like, how the hell does this work?
Pretty
Like,
far up north.
Yeah, no, recursion is a pain in the ass. Mostly when you're trying to figure out the time complexity, like it adds like another level of complexity to it. It is